Hi there. This will be about solving right triangle problems. So when we're dealing with solving for right triangle problems, we need to keep a couple things in mind. For trigonometry, we have the three ratios that we can see on the top here. So we've got sine is opposite over hypotenuse, cosine being adjacent over hypotenuse, and tan opposite over adjacent. So these are ratios because there's a relationship of the side lengths to an angle. So if we're looking at the sine relationship, we have the opposite side from angle A in relation to the hypotenuse. So that would be sine. For cosine, it's the adjacent side to the hypotenuse in reference to angle A. And for tan, that's the opposite side and the adjacent side with reference to angle A, to work with some information using the tan ratio. So the question on the right, the diagram there shows an unknown angle, a side length, and a hypotenuse length. So we've got the question, what is the angle of elevation of the kite to the nearest degree? So we're looking for the angle from the ground up. Okay, so in this case, the word elevation means to elevate from the ground. So we're going from here up. Okay, so that's what we're actually looking for. So what we're given is a measurement next to that angle and a measurement across from the 90-degree angle. Okay, so anytime we have a 90-degree angle, the measurement across from it is the hypotenuse in this right triangle. So if that's the hypotenuse, we need to figure out what this number is. Well, it's the one that's next to, and next to is like an adjacent, kind of like a neighbor, someone that's next to you. So this is the adjacent number. Okay, so when we look at our options of sine, cosine, and tan, we need to pick a ratio that's got hypotenuse and adjacent to help us figure out this angle here. So we can see that there's hypotenuse here and here. There's nothing for tan, so tan's out. So let me just look at the top. There's the adjacent. So we're using cosine. Okay, so cosine is going to be the one we go for this one. And as a kind of a quick shortcut for remembering what these are, I'm pretty sure you would have heard this, but SOHCAHTOA. What this is all three ratios summed up in 9 letters. So sine is opposite over hypotenuse. Cosine, so cosine is adjacent over hypotenuse, and tan, so the T for tan, opposite over adjacent. But we've already established that we have hypotenuse and adjacent, so we know that we're using adjacent hypotenuse for cosine, so we're using the cosine ratio. Okay, so we'll just go and set this up a little. So when we're actually working on this, we want to make sure that if we're looking for a degree, our calculator is in degree mode. So we go and hit enter on that. So now we're in degree mode. So second function mode, back to the main screen. And we want to figure out this angle. So we're going to go, see this -1 on cosine? That means second function cos. You can see a little -1 pop up. And now we're going to put in the numbers that we're dealing with. So next to, so adjacent, we'll just go through and put that on there. So the angles here, the number next to it is the 42.9. So it's 42.9 over the hypotenuse of 47.3. Okay, so we go and we put those numbers into our calculator. So 42.9 over 47.3, closing bracket. So we get 24.9, so that rounded will be 25 degrees. So we want the nearest degree in this case. Okay, so that's that one there. Moving on. What angle does the loading ramp make with the ground? So we're looking for this angle here, and we want, again, to the nearest degree. Okay, so let's just look at what we're dealing with. We want that angle, okay, and we have all of this information on the bottom, a whole bunch of different lengths for each of these small portions, and then we've got the height given as one number. So let's just think about what we need. It's asking for the angle. Okay, so we're going from this angle. Then we have an opposite side and a bottom. We can just add all these numbers up. So we have an opposite and an adjacent. Can you guess which one it is from SOHCAHTOA? Let's just keep in mind SOHCAHTOA again. Okay, so if we have an opposite and an adjacent side, we're dealing with 10. So that's this here. So again, we asked for the angle. So we're going to go 10 minus 1 in brackets. We need to do a little work on it just before we get to the bottom, the adjacent, because we need to add all these up first. But we do know that the opposite from that angle, so the furthest number away from that angle, is 1.3. So 1.3 over the adjacent. The adjacent is the thing we're going to have to work out first. Okay, so we're going to have to add all these numbers up. So it's just going to be 0.9 plus 1.2 plus 1.7. Okay, so we'll go and do that. And we get to 3.8. So we'll put that on the bottom. And then we'll just go through and work that out. Again, don't forget to make sure your calculator's in degree mode and get the second function tan button. So 1.3 divided by 3.8. So we get 18.8. So again, rounded, we'll get 19 degrees. Okay, next part down. We're asking for the lengths of y and z, or z, depending on your preference. So we're looking for these heights. Okay, so those are the support braces. And now we're asking to 1 decimal place. So again, keep in mind, what are we dealing with? Sine, cosine, or tan? So SOHCAHTOA, which one is it? But we have for the z here, that small triangle. We already know the angle. It's 19 degrees. We just need the heights for each of these. So let's just go through and organize that a little bit. So we know that's 19 degrees. Okay, so let's keep that there. And then we'll go for the first one. Okay, so we're going to go from 19, we need opposite over adjacent. So again, that's going to be 10. So we're going to go, we want the lengths for this one. So we're going to go 10 of 19. We know that this angle is 19. We just calculated that in the previous part. So it's 10 of 19. We know that we're dealing with opposite over adjacent. So the opposite side in this case is z. The adjacent side is 1.7. We don't have to add anything to get that. So it's just there. From here, our unknown is right here. That's a z. So algebraically, we would just multiply 10, 19 by 1.7. Or for those that like the shortcut of cross multiplication division, keep in mind this is not algebra, it's just a shortcut, but we can multiply 10, 19 by 1.7, divide by 1, you get the same thing. Okay, so we'll do that. So let's clear that out. So we're going to go 10, 19 times 1.7. Okay, we get to 0.5 and we wanted, what is it, 1 decimal place. Okay, so we're going to go 0.6. And this is meters. Okay, let's do the other one. So we're going to go for y. It's going to be very similar steps. The only thing that's going to be different is this bottom number. Okay, it's a little bit longer. So we just add those two numbers. So to get the bottom, we're going to go 1.2 plus 1.7. Okay, so just keep that in mind. So 10 of 19 equals to the opposite. In this case, opposite is y. Y over adjacent. So on the bottom, you add them up. So we're dealing with 2.9. And again, if you want to use that shortcut, you can just put everything over 1, cross multiply and divide, and you'll have the value of y. Okay, so let's keep in mind we're looking for y. So tan 19 again times 2.9. So we're doing the cross multiply, then divide by what's left over, in this case the 1. So if you wanted to technically show that, a division of 1 again. So that's the same thing as before. Okay, so then we round that to the nearest tenth. It wants 1 decimal place. So when we're looking at our answer, you can see this 9. We're going to use the 9 after it to round it up. So technically that becomes a 0. Now we're dealing with 1. So what this rounds to is 1, put the 0, because it's the 10th, it's 1 decimal place, meters. Okay, so 1 meter. Moving to the next part. We are laying a drainage pipe for a septic system. Scenario is for every 3 meters of run, there should be a rise or a drop of 2.5 centimeters. Okay, so we want to know what angle we're dealing with. So the angle that we're looking at here is that one there. Okay. And the only thing is we have different units for these, so just got to be careful what we're doing with those. So we'll make 3 meters into centimeters so that this number is not super small. So let's just look at what we're dealing with. So we want this angle is what we're looking for. We have an opposite and we have an adjacent. So thinking about SOHCAHTOA, opposite adjacent again is 10. Okay, so we're going to go 10, and we want that angle. So it's going to be -1. The opposite, which is 2.5 centimeters, over the adjacent, keeping in mind that converted to centimeters, you just times this by 100. That's 300 centimeters. So that 300 is on the bottom here. That'll give us an angle. Okay, let me just go work that out. So in this case, second function 10, because we want the angle, 2.5 over 300. And we get to 0.477. But again, this is a degree, so we want this in degrees. It doesn't say to the nearest degree, and we're going to make it a little bit easier to work with though. Half a degree. So it's got half a degree in terms of what we're looking at here. That's the angle. Okay, Leaning Tower of Pisa. In this case, we are looking for the tilt. So we're looking for this angle here. Okay, so it's kind of a small angle, but if we're looking at this triangle, we have the measurement that's opposite from it. So far we're dealing with sine or tan. Okay, but then we have this 55.23, which is across from this 90-degree angle. So we're dealing with hypotenuse. So we're dealing with the hypotenuse here and an opposite side length. So we're dealing with sine. So we're dealing with the SO part of SOHCAHTOA. Okay, so if we're dealing with sine of an angle, don't know what it is, with the opposite side over hypotenuse. Finish setting that up. We have sine of an angle, again, that we don't know. Opposite being 3.85 over hypotenuse, which is 55.23. Then to figure out the angle, second function sine, put those numbers, 3.85 over 55.23. And then for that angle P, let's figure that out. So now we're going to use sine. Again, make sure that you're in the right mode, degree mode, still good. So we go second function sine. And we go 3.85 over 55.23. and we get almost 4. So we round it to 4 degrees. Okay, so that slight angle is 4 degrees. Looking at this scenario here, we've got, after an hour of flying, a jet has traveled 300 miles. So that's distance, this distance here. But winds have blown the jet off course. It was supposed to be over here, 48 miles away. How many degrees is the jet off course? So what we're looking for is this angle. Okay, so just keep that in mind. Again, what are we dealing with? Sine, cosine, or tan? So SOHCAHTOA, which one? So we want this angle. We have an opposite. We have a hypotenuse. That 300 is across from the 90-degree angle again. So we have opposite hypotenuse. So we're dealing with sine. So sine theta, whatever that angle is opposite over hypotenuse. Okay, so we're just going to go and fill this in right away this time. So sine, second function, opposite of 48 over hypotenuse of 300. And go and work it out. In this case, it wants it to 1 decimal place. So we'll go and we'll do that. So we have second function sine 48 divided by 300. We get to 9.2 because it wants to the nearest 10th, 1 decimal place. So we're dealing with 9.2 degrees. Okay, moving to the next one. We've got a tower here. It's got a base value given of 48 meters and an angle of 65 degrees. So this person, Patricia, is at the Peace Tower in Ottawa. She's using a theodolite, and that's just a tool to measure visually with her visual tool to figure out the angle. So she points it up and gets this reading of 65. So the device is 1.5 meters from the ground. Okay, so that technically means that we're a little bit further. Okay, so to do this one, you're going to have to take that into account. 1.5, you're going to have to actually add that on at the end. Okay, so we want 1 decimal place for this one. So this diagram looks a little bit different because technically what we're dealing with is something like this. Okay, where that angle is still 65. The height is unknown. However, there's this height where the measurement was taken. So if this person's standing there holding it, and their height was 1.5 meters, that needs to be taken into account when we're done. So we want to actually add that in. Sorry for the diagram, not the best drawer. Okay, so we're dealing with 1.5 meters. So again, we're back to that thought of what are we dealing with? What am I given? So I've got an angle. I have a height that I'm looking for, and I know a distance from that person that's measuring of 48 meters. So we have something that's adjacent and something that's opposite. So we're dealing with tan for this one. Okay, so we're going to go tan of 65, because we actually know the 65. I'll just fill it in generically first. So tan is opposite over adjacent. Okay, so what we're dealing with is tan of 65 degrees, which equals to the opposite side that we don't know, the height over the adjacent that we do, 48 meters. Again, use that shortcut, drop a 1 below the tan, cross multiply and divide. So we're going to multiply tan 65 by 48, divide by 1. So again, tan 65 times by 48. And if there was something other than a 1 there, you'd see a different number here, but it's just a 1. So we're still at 102. Okay, so I'll just put that height there, 102.93, etc. But that's not enough because the actual height of the tower has to take into account that 1.5 meters. So that's why this diagram is a little bit deceiving. There needs to be that height taken into account. So we're going to take 102 with the whole decimal. I just rounded it here, but we're going to take the whole number from the calculator and add that to the 1.5 meters that's above the ground. So we get the full height. Okay, so just go back to the calculator, take that number and add 15 to it. Oops, 1.5. So the actual answer for this, and it wants to 1 decimal place, is 104.4. And that's in meters. Moving to the next one. Here we are looking at Roxanne sitting on the ground here at location R, watching fireworks, and they go off directly above her head. So they're coming from over here and shooting up over her head here. It's saying at what height above the ground does it explode to the nearest yard? So we're going to round. So we're looking for this height. And then it says how many yards does it travel before exploding? So we're looking for this distance. Okay. So for part A, we want to find the height. So again, let's just analyze. What are we dealing with? Sine, cosine, or tan. So we have an angle. We have something next to it, so adjacent. So we've got adjacent. We want the height, which is opposite. So we're dealing with tan. So we're going to go tan. Put the angle right away. 62 degrees. Opposite, we want the height over what we know as the adjacent, next to the angle, so 40. Again, drop that 1 below for a nice quick shortcut, or use algebra. Either way, you get the same answer. So tan of 62 times 40. And you can divide that by 1 or just leave it. Okay, so nearest yard. So we're rounding to 75. So the height here is 75 yards. Okay, part B. We want the hypotenuse of this triangle. That's what it's asking for. So now we have a height we just figured out, 75. We have 40, we have 62. I'm going to take the non-rounded number. 75 is a rounded number. I'm going to use 40 and 62 to help find the hypotenuse. So we are looking for the hypotenuse. So we know it's either sine or cosine. We have an angle and a number next to it, adjacent to it. So we're dealing with cosine. It's adjacent over hypotenuse. So we're going to go cosine of 62 equals the adjacent side of 40. So that's coming from down here, divided by the hypotenuse. In this case, this is the unknown, C. So this is where that shortcut is handy. If you were doing algebra, there's a few more steps. And again, both ways will give you the right answer, but just keep in mind, the shortcut is not algebra. It's just nice and quick to get there. So we're going to go cosine of 62. Do the same thing we did with the other steps. Cross multiply. Oops, we'll start at the other one. We need to start on 1 first. So we're going to go 1 times 40, because that's the cross part. We're going across. So we're going to multiply across, get your answer, then divide by what's left over. In this case, cosine of 62. We get to 85, and the rounding was, again, to the nearest yard. So 85 yards. So C, in this case, is 85 yards. So the distance that the fireworks actually traveled was 85 yards, even though it was only 75 above her head. Thank you for watching.